Well, hey everybody, and welcome to the easiest day of pre-calc. We're doing some angles today. Page 187 is what you'll need from your book. And you can probably already do all of this, but it's the basics that will carry us through, and the basics really kind of matter. For a long time, we'll be doing this, drawing these angles. It doesn't go away. Of course, before we get into drawing the angles, let's just have a quick little reminder as to what some angles are. Acute angle is an angle that is between 0 and 90 degrees. An obtuse angle, random, this one has a measure that's between 90 and 180. We do have the angles bigger than 180, but obtuse, the definition is up to 180. Not 180, but up to. Right angle, of course, very important that it's marked correctly with that little box, and this one always equals 90. And then a straight angle, of course, if this was our vertex, this equals 180 degrees. Now, really what we're going to do today is we're going to draw some angles. And so down here, kind of describes it all to you. And says we have to draw this in standard position. So we're drawing an angle in standard position, and the standard position has two parts, the initial side and the terminal side. Now, for us, the initial side will always be the positive x-axis. So that's going to always be our initial side. The terminal side is going to be something you draw. So you will draw the terminal side, and then you'll decide where that belongs. Some other things that you have to have. You have to have this little arrow showing the direction at which it spun, where it started, and where it landed. So that's really what we're going to focus on, is drawing these things correctly. This is the spin the type of spin we prefer when dealing with the unit circle. This is a counterclockwise rotation, where this one is a clockwise rotation. Now we do them both. Counterclockwise is a little bit more prevalent, but clockwise, if you can't tell where the arrow goes, it went down. So counterclockwise is up and clockwise is down. For us, counterclockwise will be positive angles, and that's important, and clockwise will be negative angles. So we don't just have between 0 and 360, we really have between negative infinity to infinity. So we can spin these angles any which way for however many degrees we want. So we're going to draw them. So each one down there, number 2, is kind of described. I'm just going to kind of put them on here randomly. It says 2A, 1/4 of a complete counterclockwise rotation. So counterclockwise means we're going up. So when you draw this, please indicate your X and Y axis always. And we always start right here. This is where we start, and we're going up 1/4 of a rotation, so we're going to land right there. And of course, you want to also include the angle measure is 90 degrees. For 2B, we're going half, so 1/2. So here's our XY axis. Again, draw that. We always start right here, and we're going clockwise, so we're going down. So again, the arrow would end up here, pointing to where it ends, and then you give the angle measure. We went down, so it's negative. For part C, it says 1 complete counterclockwise rotation, or otherwise known as the angle formed by rotating until it coincides with itself. So it says counterclockwise, so we're going up, and then you come all the way around. Now, if you would offset that so that they don't line up perfectly, and we know once around is 360 degrees. So you want to avoid it looking like a circle, because we cannot tell where you started and where you stopped. So it's important that they are kind of offset, whether you go a little bit beyond to the right or you want to come a little bit beyond to the left. So please make sure that we can see the arrow and we can see the direction that it's spun. For D, we're looking at 1/8. So 1/8, 360 divided by 8, that's 45 degrees. And so we are going in the negative direction. This is an eyeball. I mean, we can pretty much tell that it's about halfway, and then of course this is negative 45. So you draw the arrow and you draw the terminal side. We haven't had to draw the terminal side yet because it's always been an axis. Then for part E, this one is a big one. So for part E, we're going 2 1/3. So we're going 360 plus another 360, and then 1/3 of 360 is 120. So then we're adding 120 to this. So we're going a total of 840 degrees. Or you could just take 2 1/3 times 360. But I like the way it's described because then we can draw it a lot easier. But we do need the 840 because we're going to label that. So we're going around and around, so you got to be really careful with how you draw this. So here's 1, see how we're off-centered? 2, I can see that I spun around 2 times, and now I have to go 120 degrees or 1/3 of the way, which is, that's not to 180. Also, then you draw where it stops. So I want to be able to see that it spun around. Do not draw it so that it spins on itself and nobody can tell what you're doing. Spread the spirals out so we can count them and see exactly how many times it rotated. And of course, we calculated this as 840 degrees. Drawing these angles, it may seem silly, but it is a super big deal and something that really never goes away. Now we're going to talk about coterminal angles. Now, because we can spin this in any direction we want, as many degrees as we want, there's an infinite amount of angles that stop at every spot. So like, for example, let's just take a look at 45 degrees, right? Just plain old 45 degrees. I can get there by going up and just going the short way. I can get there by going down and going the long way. I can get there by going all the way around plus a little bit more. And of course I can get there by going down all the way and then plus a little bit more. So, oops, I'll go all the way to here. And then we can keep doing that. I can go around 4 times, I can go around 5 times. So it really never ends. All of these angles are considered to be coterminal because they all stop right there. Now, they're not all 45 degrees. Some of them are super large, some of them are negative. So when doing this, it's pretty easy to do with the arithmetic. We are trying to find 2 positive angles and 2 negative angles that are coterminal with the given angle. So basically, we add and subtract 360 until we get as many answers as we want. Now, you could give answers in the tens of thousands of degrees if you'd like. Generally, people give the answers that are closest to 0, but you can go ahead and go crazy if you want to. So if we do 60 plus 360, we get 420. And then if we add another 360, we get 780. And then we go the other way. Now, the order matters. We have to do 60 minus 360 because you want it to be negative. So then we would have negative 300 degrees, and then minus 360, negative 660 degrees. Again, the degree symbol is essential. Again, here we're adding and subtracting 360 over and over again. So negative 100 plus 360 is 260. Add 360 to that, we get 620. And again, negative 100 minus 360 is negative 460 degrees. And then another minus 360 is negative 820 degrees. So for this, we're just going to keep subtracting 360 until we get it down to where it's between 0 and 360. So I think you have to subtract this one twice. You don't have to write that down. I'm just showing you we subtracted it twice. It's 170. For this one, we just keep adding 360 over and over and over until it becomes, well, first of all, look for when it's positive, but don't go too far because you don't want to go past 360. This one is actually 90 degrees. Now, something that you did in geometry is coming back. We're going to talk about arc length. So you have this arc right here that you know is a degree measure. But we are interested in kind of cutting it off and flattening it out and measuring it like that. So we're interested in the length. This is the length, like measured in millimeters or inches or miles or something. And so we need the fraction of the circle. So how many degrees over 360 is it? And then we multiply by their circumference, 2 pi r. That's it. It's pretty simple. Portion of the circle times 2 pi r. Now for us, we're going to put this in the calculator. Maybe in geometry you left it as like 2 pi, like 3 pi over 12 or something like that. All right, so for this one we have a 60-degree angle with a radius of 8. So we're going to take the 60 degrees and put that over 360, and there's the fraction of our circle, times 2 times pi times the radius. Now, because we're doing this in the calculator, you can just straight up put that into the calculator. When you do that, you can put it in straight across the top, and then, of course, just hit divided by 360 if you'd like. Make sure you can put this in the calculator correctly. We're going to the nearest hundredth, and we get 8.38 inches. Here we have a 210-degree angle, which is certainly allowed. So 210 over 360 times 2 times pi times the radius, which is 30. Put that in the calculator. We'll get 109.96 centimeters. Now for number 5. We do a lot with wheels. I don't know why that matters, but we do. So a wheel with a radius of 20 rotated 80 degrees as it rolled along the ground. How far did the wheel travel? So again, it's worded there to try to make you think it's tricky, but we do 80 degrees over 360 times 2 times pi times 20. Put that in the calculator, 27.93 inches. Now with the clock, we have 360 degrees in the clock and 60 minutes, right? If we think about what a clock looks like. So basically we divide this out. This is 6 degrees per minute. If that matters, if that helps you sort of figure this out. There's lots of ways to do these. I'm going to try to just do it the most straightforward way possible. So we have a second hand of a clock that's 6 inches long. Now the second hand does reach all the way. So we're going to call the second hand the radius. All right, so that's essentially the radius. If you're not familiar with the second hand, that's what we're calling it. So we want to rotate 4.5 minutes. So 4.5 times 360 degrees equals 1,620 degrees. So that's how many degrees it rotates in 4.5 minutes. How far does the tip of the second hand travel in 4.5 minutes? Well, this is a distance question. This is an arc length. So the angle, 1620, goes over 360, like all the angles do, times 2 times pi times 6. And we get 169.25 inches. Now for this next one, there aren't any numbers. It says, what is the major arc AB? Oh, the length, sorry. I skipped that part. So we don't really have any information on here, which is unfortunate, but we can read the graph, and we can see that this goes to 5. So we know that the radius is 5. Now what's tricky about a radius is we can spin it and we can put that radius anywhere. So they've chosen to put it right here. So remember, the radius can spin anywhere, and that's important to know. It's still the radius, so it doesn't change. But now we need the angle. And you can kind of tell that this runs right through the middle of each square. So this is a 45-degree angle. So from here to here, it's half of the circle, which is 180, but it's 45 degrees away from it. So that part of the angle, you can calculate that. Or what they're really asking you for is the major arc. This one, we can calculate that one just straight away if we wanted to. It just depends on how you want to approach the problem. That one would be 180 plus 45, so 225. That's the one I'm going to use. That's the way I would do it. So 225 over 360 times 2 times pi times our radius. So we get 19.63. Don't have any units, so we'll call them units. Now, I know we haven't used our book very much, but there's a few more questions that I'd like to go over with you. Sometimes the check your understanding questions are the ones that really are the most difficult. So I'd like to talk about this one right here. It says, write an expression that generates every coterminal angle. Every single one of them. An infinite amount of angles, if you would. Well, we know the process is to take the angle. Whoops, this is 78 degrees. Just making up my own problem here. This is a 78-degree angle, and we know the process is to take the angle and to add and subtract 360. Well, the problem is we don't know how many times we would add and subtract 360. We saw various things on the page before. The trick to this is to put the k after it. And then k is any number, really, any real number. Because a k could be 1.5, k could be a negative 2.6, k could be a 1, k could be a 0. So k could be any number at all between 0 or between negative infinity and infinity. So we're just going to go with k at the end of that. You don't have to identify this every time, but k is the letter that we use instead of x for that. Now your assignment is right here on this page. We're going to do 10 through 14. Oh, page 189.